Okay, so today we are in section 6.5, discounts and markups. All right, so just a quick overview of what is a discount and what is a markup. A discount is a decrease in the original price of an item, and a markup is the increase in the original price of an item in order to make a profit. Right, so there's not exactly like a space on your notes for this, so you don't necessarily have to write this down, but it's just important to know, like, what is a discount? It's when something's on sale and you pay less than the original price for that item. And a markup is when you pay more than the original price for an item. So that's what we're going to see in the breakdown of the examples. All right, so in example 1, we see that the original price of a video game is $35, and it's on sale for 25% off the original price, and it's asking us what is the sale price. Okay, so we are going to use the percent equation actually to solve these, okay? And remember, the percent equation is your A equals P times W. Okay, A equals P times W. All right, and what we need to understand is W is going to stand for our original amount, okay, or our starting amount. All right, so we know that the percentage is 25% off the original price. Well, in order to figure out what value we plug in for P, we need to subtract in this case, because it's a sale. We're going to subtract 25 from 100, okay, to find our percentage. So 100% minus 25% gives me what percentage? All right, you should be writing 75% down, right? So we're always, when it's on sale, we're just going to subtract whatever the percentage is from 100, and then we're going to change that into a decimal to plug it in to our formula. All right, so A equals, now A is going to stand for our sale price, the percent, which is 0.75, times the original price, which is $35. Okay, and that price is $26.25. All right, and that's the sale price. All right, so again, W is going to stand for our original price. My percentage, if it's a sale, it's going to subtract from 100. If it's a markup, we're going to add it to 100 to figure out what we plug in for P. All right, so that's for the sale. Now let's kind of flip the table a little bit and let's find retail price. So we know that with any business, in order to stay in business, whatever they pay for a product from a wholesaler, they have to mark it up by a percentage to make a profit. So that's what we see here. A store acquires, they get a surfboard for $150. Now they have to mark up the surfboard and of course stay competitive with their pricing, but they mark it up by 60%. So what is the retail price? Well, remember, we're going to use the percent formula, A equals P times B, or I'm sorry, W, where W stands for the original amount that was paid for, either the original amount before it goes on sale or your wholesale amount, right? But in order to figure out P, I have to compare it to 100, okay? Well, 100%, and now since this is a markup, I'm going to add 60%, which gives me 160%. Okay, so basically what I'm saying is my final price is going to be 160% of my original price. So plug in 160 as a decimal in for P. A equals 1.6 times 150. Okay, now this is no different from the first slide, except I'm adding my percentage to 100 because it's a markup. Okay, and then I change that value to a decimal, and 1.6 times 150 is $240. Okay, $240 is the new price, okay? And that's how much you pay for it. So the store paid $150, but they sold it to you for $240 so they could make a profit and pay their employees and keep the lights on in their store, okay? So that's finding basically the new price. If I know the original amount and I know the amount of the markup or the discount, I can use percent equation to solve for the new price. In example 2, it kind of flips the table again, and now it says, okay, well, here's your ending price. Now you need to work backwards and figure out what your starting price was. So if baseball cleats are on sale for 40% off and the new price is $33, what is the original price? Okay, well, we're still going to use the same model of the percentage. Okay, this is not what I plug in to A equals P times W. I don't just plug in 40%. I need to take my percentage, and what do you think? Would you add or subtract it from 40%? What do you think? All right, if you're saying subtract, you're right, because it's on sale. So we go 100 minus 40. This is something really and truly you could do in your head. This part of it, 100 times 40, I'm just showing you what that looks like. This is going to be 60%. That's the value I'm plugging into my formula. But remember, change it to a decimal. But now here's the difference. Remember, W stands for the original price, or the original amount. A is basically your new amount. Well, now you know what you're walking out the door paying. So 33 goes here, equals the percentage as a decimal, 0.6 W. Now you divide both sides by 0.6, and W equals 33 divided by 0.6, which is 55. I'm sorry, this isn't, yes, this is W, sorry, $55. So what I'm saying now is if I pay, let's go back up to the original, if I paid $33 and that was the price I paid after it had been marked down 40%, that means the cleats were originally $55. Right, so again, W is the original amount and A is your new amount. So it just depends on the information you're given as to which one you're solving for. All right, last slide. Okay, so we've got a real life scenario. Okay, sorry about that. I just hit a little glitch. So sorry if I repeat myself, but we're on example 3, and basically here we're trying to figure out where these values fit into our percent equation. All right, so we have A equals P times W. Okay, where remember W is like our original amount, and P is our percentage, but remember we have to take into account the 100% starting point, and then we've got to figure out which value the $70 is. So let's start with our percentage. All right, so I want you to try to figure out, what am I going to do with 20%? Am I going to add it to 100, or am I going to subtract it from 100? All right, and if you say add it, you're exactly right, because it's a markup. So you go 100 plus 20. Okay, is 120. And then you got 120%. But remember, you have to change it to a decimal when you plug it back into the equation. So you've got 1.2. Now we need to figure out where 70 goes. So a store pays $70 for a bicycle. And it says, what is the selling price when the markup is 20%? Okay, so the $70 part of it, okay, that's what they paid. That's the wholesale price. So the 70 goes here, and your out the door price or your new price is what you're trying to find. So 1.2 times 70 gives you the selling price of $84, okay, or your new price after the markup. All right, and that's pretty much everything you need to know for section 6.5, and we'll do a little bit of classwork on these types of problems in class when I see you next. All right, guys, thanks.